So here's a somewhat challenging example. It's something that you can find in an exam. Let's just focus on part 1. So given that the logarithm of 3 is 0.4771, evaluate the logarithm of 81 without using tables, and obviously without using a calculator. So how do we go about it? We're obviously going to have to use one of the rules, basic rules of logarithms. But which one? Okay, so you want to find the logarithm of 81 using the fact that the logarithm of 3 is 0.4771. Well, that means you have to find a way to write the logarithm of 81 in terms of the logarithm of 3. So what's one way to do that? Well, you can write 81 in terms of 3. How? Well, 3 raised to the power of 4 is 81. But assuming you didn't know that, you could try that as a first step. You could say, okay, let's see what 81 divided by 3 is. And what you get is, 3 and 8 is 2, 3 and 21, 7. So you know that 81 is 3 times 27. And there's no way you wouldn't know that 27 is 3 raised to the power of 3. Or at least you know that 27 is 3 times 9. And 9 is 3 squared. So you know that 27 is 3 cubed. So now you know that 81 is 3 raised to the power of 4. So I'm looking for log 81, which means I'm looking for log 3 raised to the power of 4, which means I'm looking for 4 times the logarithm of 3. We've been told that the logarithm of 3 is 0.4771. So the answer is 4 times 0.4771, which is 1.9084. It's that easy. In part 2, the statement here is that if the logarithm of 2z squared, so this is one term, minus the logarithm of 4z plus 2 is equal to 3. So if that equation is true, find z. Well, what they're asking us to do is actually make z the subject of the formula, because you're trying to find z. So you want to be able to say that z is equal to something, which is tricky here because you have logarithms. So we need to find a way to somehow get rid of the logarithm, because you are looking for a numerical value of z, or maybe you can even write z in terms of the logs, who knows. But let's see. Let's try and break things down. Or simplify things. So I will show you a step, and then I'll show you the logic behind it, and then anytime you have a scenario where you can apply the logic, please do. So what I'm going to do is I'm going to keep all logarithm. I'm going to group like terms. Anything that is a logarithm of something, I'm going to put it on one side of the equation, and everything that's just a number, I'm going to put on another side of the equation. So on my left hand side, I'm going to leave the logarithm of 2z squared. I'm going to leave the logarithm of 4z. Plus 2 is going to be taken to the right hand side, so I'm subtracting 2 from both sides. So that gives me 3 minus 2 on the right hand side, which is 1. So what I've done now is I've just subtracted 2 from both sides. So you can write that down if you're like in an exam showing your steps. You can say subtract 2 from both sides. So that's easy step to follow. You can carry out subtractions. Next step needs a bit more thought, and you need to be able to recall a rule in reverse, because you know that, so just write that here, the logarithm of p over q is equal to the logarithm of p minus the logarithm of q. So if you have a situation where you see something of the form log p minus log q, you can always write it in this simplified form. That's what I'm going to do here, because in this case, my p is 2z squared and my q is 4z. So I can write this as the logarithm of p over q, which would be the logarithm of 2z squared over 4z, being equal to 1. And there are two ways to progress from here. The first, first of all, we can actually carry out some simplification. So 2 here, 1, 2 and 4, 2. And then z squared over z. 1 z will cancel 1 z here and leave z. So what am I saying now? When you have z squared over z, it's the same thing as z times z divided by z. So z here 1, z here 1. So you're left with 1 more z. So doing all that gives log z over 2. So go and review algebraic fractions and the manipulations if you didn't understand that step. So what I have here is log z over 2 is equal to 1. So there are two ways you can progress. Firstly, you can just say, well, that means that 10 raised to the power of 1 is z over 2, which means that z over 2 is 10, which means that z is 20. And that is a z, not a 2. Z is 20. Another way is to say, well, 1 is the same thing as the logarithm of 10. So by comparing both sides, because you have something, you're saying the log of something is equal to log of something. So those two things must be the same. So z over 2 must be equal to 10. So z must be equal to 20. So that's another way. But the first way is the most direct way that will always work. Anytime you have a situation, log of x is equal to y, you can always get rid of the log sign by saying, because remember, log x is the same thing as log x to the base 10. So the rule is you can always say this is same thing as 10 raised to the power of y is equal to x. And this all comes from what I mentioned in the introductory video about the meaning of a logarithm of a number. Logarithm of a number, logarithm of a number to base 10 is some value, and it's always the value that you raise 10 to give that number. So what's the logarithm of x to base 10? It's just saying, what will I raise 10 to give me x? And that's y. So in this case, you have the logarithm of z over 2 is 1. It means that if you raise 10 to the power of 1, you get z over 2, and all of a sudden you just have an equation that you can simplify to give z. So in this part 3, we've actually been told that we should take log 6.35 to be equal to 0.8028, which means that this piece of information will be very useful in solving the question. At least it will make it simple or simpler. It's basically a hint and you should use it. If you're not using it, then you're probably going in the wrong direction. So how do we proceed and how can we use this hint? Well, let's get rid of this cube root symbol. You know that x raised to the power of 1 over 3 is the same thing as the cube root of x. So ignore the log for now. You'll have the cube root of 0.00635. I can rewrite it as 0.00635 raised to the power of 1 over 3. So that's one thing. The next thing is, you can see 635 here, you can see 6.35 here. So why not just convert this to standard form? So instead of 0.00635, you can rewrite it as 6.35 times 10 to the power of minus what? 10 to the power of minus 1, 2, 3. 10 to the power of minus 3. So what we have is so the logarithm of the cube root of 0.00635, the logarithm of this term is going to be the logarithm of that term. So what we're now interested in really finding is the logarithm of this term. So I'm going to still try and simplify this term. Well, I can't. So the logarithm of this, okay, I'm just going to write it down. So we're asked to find logarithm of that. Well, that's the same thing as the logarithm of, because this is the same thing as that. And from the rules of logarithm, you know that if you have something in the form log p to the n, you can write it as n times the logarithm of p. In this case, our n is 1 over 3, and our p is this whole term here, log p raised to the power of n. So I'm going to write this as 1 over 3 times logarithm of 6.35 times 10 to the minus 3. I'm going to continue here. So I have 1 over 3. So it's 1 over 3 times the logarithm of this. But you know that the logarithm of a number times another number is the logarithm of, so the logarithm of a times b is logarithm of a plus logarithm of b. Logarithm of p times q is logarithm of p plus logarithm of q. So the logarithm of 6.35 times 10 to the power of minus 3, the same thing as the logarithm of 6.35 plus the logarithm of 10 to the power of minus 3. Okay, it's a bit trickier here, but this log 6.35 times 10 to the power of minus 3 is the same thing as, let's use a different color. Same thing as log p times q, which we know is log, can be written as log p plus log q. So that's what I've done. So moving on, I have 1 over 3 the logarithm of 6.35 has been given as, now we're using our hint, 0.8028. Plus the logarithm of 10 to the power of minus 3, which is really the same thing as minus 3 times log 10. Therefore equal to 1 over 3 into, we're pretty much done now, plus minus 3 times something is minus 3 times the thing. But if you just focus on this bracketed expression, minus 3 times log 10. Log 10 is 1, so minus 3 times 1 is minus 3. So this bracket is essentially minus 3. So we have plus minus 3, which is obviously minus 3. So this gives us 1 over 3. I mean, you could work it out, but what you get is, okay, I'll use my calculator here. So 0.8028 minus 3 gives minus 2.1972. So times 1 over 3, which means divided by 3, gives